Let us have another question on principle of superposition. A circular steel bar having three segments is subjected to various forces at different cross sections as shown in figure. Determine the necessary force to be applied at section C for the equilibrium of the bar. Also find the total elongation of the bar. Take E equal to 202 gigapascal. In this question, we are given with different forces acting at different cross section of the bar, and one of the force is unknown. So we have to find this unknown force which is applied at cross section C so that the body is in equilibrium. And another is we are given with different diameters and length of the bar, and we have to find out the total elongation of the bar. So let us solve this problem. In this numerical, we are given with a steel bar. There is a steel bar and it has three sections. One section is 30 mm dia, another is 60 mm dia, and another is 40 mm dia. And different forces are acting at different sections of this bar. We have to find out what is the force, what force should be applied at C point, at section C, what force should be applied so that the body is in static equilibrium. One, and another is what is the change in dimensions, what is the elongation or contraction of this bar, right? This we have to find out, right? So let us start the question. Now, as you know that the body will be in static equilibrium when the sum of the forces should be equal to 0. Also sum of the moments should be equal to 0. There should not be any torque, there should not be any movement. But here, because there is all the forces in same direction, in x direction, leftward or rightward, so we are not taking here any movement because movement is by default is 0, right? So sum of the forces should be equal to 0. So forces in leftward direction should be equal to forces in rightward direction. Forces in leftward direction should be equal to forces in rightward direction. So what are the forces in leftward direction? 40 and P. This is 40 plus P. And what are the forces in rightward direction? These are 30 and 70. 30 plus 70. So this should be equal to 100 minus 40. This should be 60 kilonewton. So this is our one answer. This is the one answer, 60 kilonewton. That this force should be equal to 60 kilonewton. So I am writing here this force as this P is now known to us, which is 60 kilonewton. Now this is known, 60 kilonewton, right? So you can check 60 plus 40 leftward 100, 30 plus 70 rightward 100. So this is 60 kilonewton. Now our aim is to find out the deformation in the bar. What will be the deformation in the bar? We can apply the principle of superposition, right? That we have to find out the force in each section, and then we have to find out the deformation in each section, and we have to add up that deformations, right? So we can divide this bar into three parts. Let us say this is one section, this is 2, and this is 3. 1, 2, 3, right? And we are dividing this bar into three parts. This is AB, this is BC, BC, and this is CD. Another is CD. So this is AB, BC, and CD. These are the three sections of the bar, right? Now you have seen that there are some points which are common to the two sections, like this B point. B point is common to AB and BC. C point is also common to BC and CD, and we have to find out the forces in each bar, right? But the total force should be 30 kilonewton at B and 60 kilonewton at C, right? So let us find out the forces first in those points at those sections which are not common to any other section. Like point A, here 40 kilonewton force is not shared by any other section, So we can write here that there must be 40 kilonewton force, and because this AB is in static equilibrium, so there will be 40 kilonewton rightward also. Here the force is 70 kilonewton rightward. There must be 70 kilonewton leftward force, so that the body may be in static equilibrium. Because all parts of the body in static equilibrium, that's why AB must be static equilibrium, CD must be in static equilibrium. So 40, 40 and 70 centi tensile force is there. Now, what is the force on B? Total force on B is 30 kilonewton, but we have two sections. So we have to apply here 10 kilonewton leftward, 10 kilonewton leftward, so that 40 rightward minus 10 leftward should be equal to 30 rightward, right? So we can apply here that force on B, FB will be equal to 40 rightward in AB and 10 leftward, so 40 minus 10 will give 30 kilonewton rightward. And this, if this is 10, there must be 10 because there is no intermediate force here, so this must be 10 kilonewton, so that the body in static equilibrium. Now let us check the force in C. In force in C, 10 kilonewton force is rightward, 10 is rightward plus 70 leftward, so 70 minus 10, 60 leftward, so this is 60 kilonewton leftward. Let us check 60 kilonewton leftward, right? So these are the forces in FB and FC, so we are doing the correct way, right? Now we have to find out the total elongation in the bar, elongation in 1 plus 2 plus 3. So we will find out delta L, total elongation will be delta L 1, delta L in 2, delta L in 3. So this is our principle of superposition, and we can utilize this formula PL upon AE, which is our basic formula we have derived in a theory lecture. PL upon AE, use this formula directly and find out the total elongation in the bar, right? So delta L total will be equal to P, force. Now force in 1 is, we can write what are the forces. Force is 1, P1 is given by 40 kilonewton tensile, 40 kilonewton. P2 is 10 kilonewton and P3 is 70 kilonewton. So these are the forces. Use this PL upon AE formula, PL upon AE. So P is 40 kilonewton multiplied by 1000, length 600 mm. These dimensions are in mm, right? All the dimensions are in mm. All the dimensions are in mm. So you can use mm, so that final answer can be obtained in millimeter, right? So 600 mm divided by area. Area is 30 mm is dia, so you can write pi by 4 d square. D square is 0.03 square into E. E is given 202 gigapascal. So 202 multiplied 10 to the power 9. So this is the first term, right? Second is plus tensile load 10 kilonewton may become Newton multiplied by length 800 mm. We are using in mm, so that final answer may be in millimeter. Pi by 4 d square. Dia of this section is 60. So this is 0.06 square multiplied by 202 gigapascal becomes pascal multiplied by 10 power 9 plus third section is 70 multiplied 1000 multiply length is 900 divided by pi by 4 d square. What is dia? 40, 0.04 we have used meter, and E 202 giga is 10 power 9 pascal. So this is the change in length. Use the calculator and find the value of change in length. It will come out to be 0.43 mm. So delta will be equal to 0.43 millimeter So this is our answer.